Welcome to this video where we want to demonstrate how you can use the Python software through the Jupyter notebooks to do data science or Python coding straight away from the smartphone. You don't require a laptop or desktop to do your computations. This is a cloud platform that we have deployed to help those users or persons who may not have access to laptops or desktops but still want to learn coding in Python or want to do data science using the Python programming language. Another group of people that we target are those who, for example, maybe yes, you have access to a computer or a desktop or laptop, but the circumstances you are in currently do not allow you, for example, to use that computer. For example, when you are traveling from one place to another, maybe you are stuck in a traffic jam, or you are in the village where there is no power, or your computer has run out of power, and you like to continue with your Python coding, then you simply can switch on to your smartphone and continue doing your programming from your smartphone without requiring the laptop. So this is an application that is accessed through the browser, and you can use any browser of your choice. In my case, I'm going to use the Chrome browser, so I just click on it, and then in that text box I'll type the website link. So in our case it's mathematics, so www.mathematics.co.ke, then press the enter key to open it. So doing so leads you to this sign in page where you need to enter your username, give the password, then hit the sign in button to log in. So for my case, I'm going to use the username STEM001. Currently I've not set a password for it, so I'll just hit the sign in button straight away, and this opens the home page for the Jupyter hub. Those who have used Jupyter notebooks on computers, either laptop or desktop, are familiar with this interface here. This is the home page. Anytime that you open your Jupyter IDE, it will always land you on this interface here. And if you had not run any notebooks previously, then this area here will be blank. But if you had saved some notebooks in your Jupyter IDE, then they will be listed in this blank white area down here. So because this is a very new session, I'd like us to start by opening a new notebook, and we do that by clicking the new icon at the top there, and from this drop down menu that pops up, I want us to click Python 3 because it's the language that we are going to use. And by default it opens a new Jupyter notebook and creates a first cell and activates it. So you can start by typing your input here, your commands inside this cell. But before you type any command, let me just say one statement about running commands in this Jupyter notebook for those who are very new to Jupyter IDE. So you type your statements inside this cell, then you need to run them. So there are two ways to run statements. The first one is you can click that forward icon to the far right of that input cell. You click on it to run the syntax that if there was any syntax inside this cell here, then that syntax will be run and the results displayed. What it will not do, it will not create a new cell. Now for me, for this top icon here, there's another top icon, a run option here at the top is known as run. So that clicking on it will run the syntax, and in addition to that will create a new cell. So for this demonstration here, we will be using the run button at the top there to run Python code. So for this demonstration, I would like us to get started by looking at a very simple example. You want to print numbers between, say, 10 and 60. So to do that, of course, we are going to use the for loop. We have said that we're interested in printing the numbers between between 10 and 60 inclusive. So I'll start by declaring those that interval. So a is equals to 10, and then b is equals to 60. B is an equal sign, is equals to 60, like that. Now we write our for loop. So we say for, I'll use n as the iterator variable for n in range. So I call the range function, which will give us the list of those values for range from a as the starting point to the last point will be b plus 1. So we are adding plus 1 because Python sequences begin from the starting value, the first value you have specified, until the last value you have specified minus 1. So because we are going to up to 60, then I must specify from 10 to 61 for Python to get to 60, otherwise it will get to 59. So I continue with my syntax like that. Then you have said the aim is simply to print those numbers. So I'll just say print n like that. Then now run that syntax. So you can see that Python has printed those all those numbers, integers between 10 and 60 inclusive. Now in another loop, I would like us to edit that loop, and now instead of printing all the numbers, I want us to only print multiples of 3. So it's the same loop, only that we are going to edit it and give a condition to it. So the condition will be that we are considering only multiples of 3. So I write the loop again. A is equals to 10, b is equals to 60. Then I say for n in range from a to b plus 1. Then I do something. So we are saying that we are interested in only multiples of 3. That means that we must give a condition for that, and to give conditions in Python, just like any other programming language, we are going to use the if statement. So if n, so we are going to tell Python to only consider numbers that when I divide that number by 3, the remainder is equals to 0. So you define that by saying n modulo 3, that's how we define modulo in Python, is equals to is equals to 0. So if I divide n by 3 and I get that the remainder is equals to 0, then it means that that indeed is a multiple of 3. So I continue the syntax, then I say, what do? We need to print those numbers. So print n like that. So that short loop will print multiples of 3 between 10 and 60. So I simply hit run, and you can see that Python has printed those multiples of 3, 12, 15, 18, 21 up to 60, as you can see here. So now in our next demonstration, I would like us to look at something a bit intermediate. This was too basic. I would like us to see how, for example, we can plot values of x and y on a graph. So to do that, I'll import some packages. Allow me to create a cell here. Just click that positive sign, then hit that up arrow to take it to the top. So I want us to import first the NumPy package. So import NumPy as np. Then also I want us to import pandas as pd. The pandas library will just be used to display the results of x, y, and z in a table. Then I also want us to import the matplotlib for plotting. So matplotlib.pyplot as plt. Then lastly, I would like us to import the SymPy. We'll be using it to do integration and differentiation of an expression. So import SymPy as sim, like that. Then run the syntax. Just run that cell to import all those packages. Allow me to add this sim.init underscore printing. That will print numerical values in LaTeX form if there are any. I rerun the cell again. So we are fine to go with those packages. So what I would like us to do, I would like us to create graphs of the sine and cosine functions between theta is equals to 0 to 2 pi radians. To do that, I start by specifying the range. So between 0 and 2 pi, we'll specify that range using the numpy's linspace command. So say x is equals to np linspace. So we begin by defining the starting point of that range and the last point, so it's 2 pi times, I call the pi function from the numpy package. Then I specify how many points I want. I want 40 points. So like that, close that, then enter. Then as you have said, what you're interested in is we want to find the sine of all those values of x and also the cosine of all those values of x. So the first one will be, you can call it y is equals to, I want to calculate the sine. So I say I call it from the numpy package np.sine x, then xz, find the cosine of each of those values of x. So I do that by calling the cosine function from the numpy package again. So cos x, like that. And then I create a pandas table from this. Now before I create a pandas table, I want to convert these three arrays into a numpy array, single numpy array. So I do that by saying x, I just call it xyz is equals to np.array, that's a numpy function. Then I put them in square brackets like that. So there is x, comma, y, comma, z. I close that square bracket, then I close the parenthesis. Then I need to transpose those values, so I just add dot capital T like that. Then I can display the results to see if it has worked. So do that and click the run button at the top there. And if you don't see the result, you will just click run again. So those are the results. Now I want to convert these results to a pandas data frame. So I say df is equals to, so I call the data frame function from the pandas library, so that is data frame. Make sure that D and F are capital like that, then into X, Y and Z like that. Of course, I can add other arguments to define, for example, column names and row names, but I just want us to be that simple. So df to display the results, then hit the run key. Well, if it doesn't run, hit the run key again. Just rerun the cell. Just rerun the cell like that. So this is the table that we get. So the first column, where the column with the heading 0, those are the values of x. Then the second column, which is indicated as 1, those are values of sine of x. Then there's a last column, which is 2, those are the values of the cosine of x. So that's the table that we have found. Yeah, they should be that 9 values. That's the actual 40 values only that Python starts from 0. So there are 40 values as we had specified within this linspace function. So now the next thing is now to plot those values on a graph. So to do that, we use the matplot library. So we say matplot, the matplotlib library. So we say plt.plot into x, then y. So I've plotted the sine function, then again x, z. That now plots the cosine function like that. Then I close that bracket. That's enough. I click the run button, and you see that that graph has been generated, the graph of the cosine and the graph of the sine function. The blue one is the sine function, the orange one is the cosine function. Of course, I have the option of adding more syntax to give the legend and maybe give the y-axis labels and the x-axis labels and the title and so on, but I will not be doing that in this video. I would like us to keep it as simple as is possible. Now the next thing I would like us to do is we want to use Python to find the integral. I'll start by the derivative of any given expression. So in this case, maybe I want to differentiate x squared minus sine x. Sorry, x squared times the sine of x. So to do that, I define that expression, say f. Now before I define it, I must first declare x as a symbolic variable. So I say x is equals to sim dot symbols, then into quotation marks x like that. So I am defining x as a symbolic variable before we can use it in the expression that I'm just about to create. So say x, now I create that expression. So f is equals to, we say that it's x squared, so it's x squared times the sine of x, so times sine of x like that. Then our aim is to find the derivative. So let me just run that cell to see how it has worked. N is not defined. Sorry, sine is not defined, so I need to define this to call it from the SymPy library, then rerun and see. So it's now fine. Now our aim is to find the first derivative. So I simply say I can call it d is equals to sim.df diff differentiation, then I specify it's f comma x like that, then I hit that to display the results like that. If you don't see the result, just rerun that statement again, and it gives you that the result is x squared cos x plus 2x sin x. That's the first derivative of the function we specified. Then the next one is we can integrate the same expression. Just say sim dot integrate then f again with respect to x like that, then run that syntax. So that's a value that you get when you integrate that function. Again, I can do this, the indefinite integral. I can perform the definite integral by specifying the limits of integration. So I just type sim dot integrate, then I say it is f comma, then the variable is x, then the limits are say from 0 until 4, until 4 like that, then I close that last parenthesis, then run the syntax. So that's the integral of that function from 0 to 4. I can write it in numeric form by adding the function EFALF into say 12 decimal points like that. So I just add that expression to convert this from this format. This is the exact answer, so but I want to display it as a decimal. Run the button, and you see that the value is 1.0965 and so on. So thank you for watching this video, and I welcome you to sign up for this in this website and use this cloud computing platform to do your analysis, Python coding, be it analysis or data science, straight away from your smartphone. Thank you once again.